Hello and welcome to Best Practices for vSAN Design, a real-world perspective. I'm Ron Scott Adams. This is my esteemed colleague, Joshua C.E. Fidel.
What up, y'all?
We are hyper-converged systems engineers in VMware's Storage and Availability Business Unit. Try saying that really fast. We help customers design, understand, and implement vSAN at scale with great success.
Is it not working for?
There it goes. Please take a note of our fabulous disclaimer slide. I'll add a little disclaimer of our own. Josh and I pride ourselves on being relatively unfiltered people.
Or completely unfiltered.
You hear a lot of do's and don'ts, coulds and shoulds. This is because we want you to have great success with vSAN. We truly believe it is the world's best way to build storage and virtualization. And we want to cut through and make things as simple for you as possible to achieve success. I want to start with a quick level set on what vSAN is, what the principles of design here are. Throughout the deck, you're going to see a lot of sessions called out in parentheses here and there. Definitely check those sessions out, either recordings after VMworld that become available, or try and attend the sessions themselves. They'll go into some great detail on some ideas behind the things that we're going to touch on. vSAN design is simple. It's to do for storage what vSphere famously did for compute. Take commodity x86 hardware and achieve a virtualization platform. But now instead of that just coming together and giving you a compute cluster, throw local media into the mix and have it build a storage cluster too. Do all of this with simple vSphere integrated administration.
So now that, hopefully you guys know what vSAN is. If you don't, I'll give you 30 seconds to leave. But when you're looking at vSAN for your organization, it's very important to think about use cases. What are we going to use it for? I've seen plenty of C-level executives that they say, we want vSAN. Okay, awesome. What are you going to use it for? I don't know, we just want vSAN. That doesn't work very well. One thing I will say is, we've sent out a survey. We're almost at 10,000 customers now. We sent out a survey. We said, what are you using vSAN for? What are you doing with it? And 83% of our customers came back and said they have business critical applications running on all flash. All right, that's huge. If we can handle running the infrastructure for the Super Bowl last year on vSAN, we can probably handle your workload. All right. So, do you want to put an app that is business critical on vSAN? Other things, databases, SQL, Oracle. We have a ton of customers who are virtualizing their SQL stuff, virtualizing their Oracle stuff. Don't be intimidated by Oracle licensing. We can help you with that. Yeah, I know some of you know what I'm talking about. DRDA. Today in a traditional environment, you've got a storage array on production, you've got a storage array at DR, maybe a little smaller, and you replicate. Let's eliminate some of that cost at DR. Let's get rid of that storage array. Let's put in vSAN and replicate to vSAN, right? vSAN works with vSphere replication. We work with SRM beautifully, I might add. Management clusters, all of us have these management tools for our environments, SCCM, SCOM, vCenter, server, whatever the case may be. And most of the time, those tools exist on servers that live on our shared storage. What happens if your shared storage goes away? Where are your tools? Right? So why not take those off the shared storage, isolate them on their own vSAN cluster? We have a ton of use cases. People love this because, knock on wood, nothing ever happens to your storage array because all storage arrays are perfect. But if your storage array goes down, your management tools are over here, guess what? You still have your tools to get things up and running. That's very important. Virtual desktops, I think we all know this is a no-brainer. We package vSAN with Horizon View. Yes, you can run Citrix on top of vSAN too. We will run Citrix, we like them. Cloud native, containers, we do both of these well. We provide stateful storage, be it through something like VIC or be it through the Photon OS. Mesosphere, Kubernetes, Docker, you name it, we can run that on vSAN. All right. And then, of course, we have our remote office, branch office. Robo is a licensing type. Two-node is an architecture. And there's a lot of confusion. Oh, we're going to do Robo. Well, are you going to do the two-node architecture, or 3, 4? How are you going to do this? Well, we're going to do Robo. Okay. So So you've identified a use case in your organization. You have to know what this thing does. Apps are complex enough, right? We don't need another self-operated napkin. We already have one. We were going to have a demo of this for you, but the TSA wouldn't let Ron's bird on the plane. So
rest in peace, Polly.
Bad sign. Anyway, so siloed infrastructure, right? We all have storage teams, virtualization teams, network teams, right? Or maybe you are all three of those teams. I've seen that. But isolation of departments adds complexity to something that's already complex. You're going to have to break down those silos to really get vSAN up and running well. And then, let's talk about what the applications are that we're going to virtualize on vSAN. Talk to your business owners. What is the business case for this application? Talk to your end users. Hey, when you use this application, how is it? Is it like super fast? Or is it the click and go get a coffee and come back 10 minutes later? You have to know what kind of latency you're experiencing, things like that. Native structures inside the application. I have a lot of customers who are running Exchange at 2 different sites, and they are replicating DAGs, right? They don't necessarily need the resiliency that vSAN can provide because they're already replicating, so they can do an FTT of 0. I don't suggest it for everything, but for a SQL always-on availability group, why do you need 3 copies of your SQL server that's just replicating to a different SQL server? Probably don't. And then, of course, you have to think about interoperability with other applications. Hey, we've got this financial accounting application. We're going to put it on vSAN. That's awesome. Does it talk to anything else? Does it feed your billing system? Do we need to include that on our vSAN cluster? Should we put it on a different vSAN cluster? You have to really get a good assessment of the applications you want to put on vSAN. And then, what do these things need? If you go check out STO1372BUR, it goes kind of into a host deep dive, which we love our host deep dive stuff. Host Deep Dive, if you haven't bought a copy, excellent book. I highly suggest it. Works better than Ambien. So, no, it is an insanely deep level of detail. I highly suggest it. I really do. But what does your application need? How much CPU do you need? How much RAM do you need? What kind of storage do you need? What's your throughput? What's your latency? How much capacity? Once you gather all this information, you want to design for the best possible hybrid of all. Your users want 0 latency. The vendor wants 600 vCPU and 2 terabytes of RAM. I'm sure we've all seen that before. But you use your common sense there, right? What is your infrastructure capabilities? Do you have a 10 gig network in place? Do you have the ports available? Do you need to add ports? Think about all these things as you're designing. Obviously, gather assessment data on your applications, on your storage throughput. Ron's going to tell you about how to do that. But if you gather all these things, you get all this information, right, and you build your vSAN clusters correctly, you're going to have a nice, quiet, sleeping baby that's not going to wake you up at 3 o'clock in the morning screaming for a bottle, demanding to have its diaper changed, right? Nobody likes that 3 a.m. wake up.
Sounds like a little PTSD there, Josh.
3 kids.
Yeah. Let's talk about assessing the workload. So you have the vendors that are going to give you certain system requirements, sort of a baseline. You have some other baseline understandings you probably have in your environment, but you really want to get an assessment of workloads that you are running at scale to understand how these work over time. And a key part of that is getting data over time. There's a lot of great inventory management tools out there. They do a fantastic job for managing and assessing inventory, but they're incidental captures, one-time snapshot, spits out a result. These are not going to be ideal for sizing in your vSphere environments and especially your hyper-converged environments because we want to see the trends of data. How does that data react over time, especially during your peak periods? VMware has 2 great tools that we can kind of start with this off the bat. There's a lot of other ways to get this data. One is vip.vmware.com. You go and you request an assessment, and we send you an assessment link. You deploy a simple virtual appliance, and away you go with great assessments. The assessment lounge is available here at VMworld, so you can talk to an expert about that more. There's also vRealize Operations. Besides its fantastic benefits out of the box and what it's commonly used for, it's a fantastic assessment tool because you're talking about a long tail of data. I can see those trends over a great period of time, and now I know when I'm gathering metrics, I know what that looks like through my peaks and valleys. When I want to look at these metrics, I want to think about meaningful metrics, but also meaningful measurements. How do I get the unit of measurement for what I'm assessing? I'm going to throw you a few suggestions. There are certainly a lot of deep dives on this. Host Resources Deep Dive is great. vSAN design sessions are also running this week that laser in on some of these ideas. But think about ideas like the 95th percentile. 95% of the time, what is something like on average? That last 5%, that extreme high, is important to note. But it's not what you're primarily designing against. There are a lot of things that make those peaks happen, and you want to design against that average point and then factor in the 5%. We'll talk about ways that we can help you with that. Think when you're designing for CPU, think more along the terms of gigahertz clock cycles you're consuming. There's a lot of voodoo about vCPU to core consolidation. Should be 4 to 1, 8 to 1, 6 to 1, 10 to 1. What should it be? What's the ideal for what workload? The reality is there's not a set answer here. There's a lot of complexity. There's a lot of skeletons hidden in that closet. If we think about the cycles we actually need in CPU time, this gives us an easier answer to start building vSAN from. In attendance with that, take in the CPU ready. CPU ready is a time that VMs are ready to process, ready for a CPU instruction, but haven't received it yet. High CPU ready time means something is stopping CPU from being distributed to VMs, whatever that could be. So we want to think about these calculations. Get a lot of questions about, well, what is vSAN going to do to my CPU? How sideways is that going to take all of my stuff? We tell people a pessimistic 10% CPU overhead. In reality, what I see out in the wild, what I saw in my own clusters when I ran at scale in the Fortune 500 financial industry, we saw about 4 to 8% as a norm. What you're going to see more or less depends on your features, cluster size, some other factors. 10% is a nice round pessimistic thing to throw on top. These CPU metrics will help you because going from 80% to 90% CPU utilization hurts a lot more than going from 30 to 40. So think about where you maybe want to buff up or even bring down that standard CPU power. On the VRAM side, consider the days of memory oversubscription to be over. For a lot of reasons, the modern application infrastructure does really well with that one-to-one, meaning for all the RAM I've assigned to VMs, assume that's going to be part of my infrastructure, assume that's going to be part of the physical RAM I assign, the PRAM I assign. On top of that, you can look at the PRAM consumed in your cluster with those great data over time tools. That'll give you an idea of some of the overhead, some of the extra on top that gets generated there. So when you take these metrics together, you get an idea of how vSAN is going to operate in terms of the memory consumed. When I have this one-to-one and I have that extra memory, I have abilities like vSAN sparse swap, where I can take all the swap files that get generated, thin them out, and not pay for the disk to store that because I'm not swapping in the first place. So this VMware KB 2113954 will walk you through in extremely nerdy detail how much RAM vSAN will use based on your disk group design. If you want a nice round number to throw out there, 12 to 14 is about what I see most disk groups ending up at. The KB will go into more depth on that as far as how that RAM is assigned. So you're going to throw a little on top for vSAN as well. For storage performance, think about the throughput number. This is a great number and it's often underserved because there's so much talk about IOPS, 1 million IOPS and this or that or the other. And that's cool. And IOPS are an important factor, but throughput is a nice simple number because it's data moving through a pipe, megabytes per second. You get into IOPS, you need to think about things like block size, random, sequential, and these all are important metrics. And a lot of you that are working on the partner side, or if you're working with partners, they can tell you a lot of the great comparative metrics and things you can understand there. But have an idea of your data rate. But in addition to the data rate, think about latency. If I look at a measurement and I say, oh, this has 30,000 IOPS, so I should be good with 40,000. That's not true if I'm getting 60 milliseconds of latency. There is an it depends there. There's a devil in the details. So take a look at those two together. Storage capacity. vSAN is thin provisioned by default. Take advantage of that. It's built on commodity hardware. The scale out for all forms that you're going to consume vSAN is very simple. Designed against a balance of what's assigned to your VMs and what your VMs are consuming. That's going to depend on your environment. I work with some customers who work off systems like, regular budgets or incidental budgets where they'll kind of sneak in a few extra disks when they need to scale and that sort of thing, and it's no problem. And some people work on the magic rainfall grants where they have to do a dance and sacrifice a goat, and then maybe they get budget for the next year. And so they kind of build a little more storage ahead of time. That's fine. Do what makes sense for your business, but design against that balance. Don't feel you need the 5-year growth factor in vSAN. Drives are getting better, faster, cheaper all the time. Do yourself a service, design against a balance of the space you need. When you take these together, now think about how you'll consume vSAN. In other words, what are you going to turn it into? How's it going to be platformed in your environment? Start by taking a look at the pre-designed solutions. These definitely deserve a close look. Talking about things like VMware Cloud Foundation. This is vSphere, NSX, vSAN, all combined into a software packaging with the SDDC manager on top to handle lifecycle. This is going to give you a comprehensive data center software environment. You can take that to a rack scale appliance with VxRack SDDC, which is going to take that and now turn it into a turnkey plug and play data center, basically. VxRail is going to take that turnkey idea down to the node level. Kind of similar to the Ready Node idea, but now I'm going to have that plug and play concept of growing my clusters quickly and having lifecycle management, the one-click lifecycle management, all the great things that come from a turnkey appliance. Architecture is about success. There's no room for a not invented here mentality. Don't think that taking these pre-designed solutions is going to mean, oh, there's no chance for me to architect or do something interesting, because there's absolutely plenty of work to be done.
I just want to interject here. I don't know if you've heard the announcement, but VxRail 4.5 is coming out, and it will have vSAN 6.6 for its storage software. So if VxRail didn't interest you because, hey, it doesn't have 6.6, very, very shortly it will. So I highly suggest taking a look at that.
Absolutely. Well, let's hit on the Ready Nodes idea. This is kind of where vSAN all started. This idea of I can take from all these vendors, and we're adding more actually, that I can take these vendors who provide systems and build a vSAN solution. Get a lot of questions, and there's a lot of variance between Ready Nodes. Like, does a Ready Node matter? Can I just kind of build a server that looks like that? Or, well, I found this Ready Node that has this CPU, RAM, and disk, and I need this CPU, RAM, and disk. What do I do? Do I have to look for another Ready Node? Ready Nodes are a template system. We did this to not make you feel like you have to search and sort through all these different hardware conjunctions. Have a template to start with. There's a great blog article on VirtualBlocks, what you can and cannot change in a Ready Node. Session STO1372BUR will cover the Ready Nodes concept in detail. Definitely look for that recording after VMworld. The idea here is start your configurations as Ready Node, even if you're doing the build your own. Josh and I have had the privilege of doing some really unique designs for customers, ranging from low-power data centers, open-air things done in shipping containers, things done in big vehicles we can't talk about that maybe have big guns on them like this, and cool stuff like that. So they have special chassis requirements. They have special power requirements. They can't just take an off-the-shelf Ready Node and say, this is our data center. That's okay. We've taken those Ready Nodes, and we've taken it. The only thing left might be the disk controller and some of the disks. Maybe the chassis and everything is totally changed.
Yeah, maybe not even the disk sometimes. Things change easily.
When you go off that beaten path, that is acceptable in vSAN. We can't say that enough. But don't be weird. When I ran data centers, I like to say that my data centers, if nothing else, for all their other flaws, they were not weird. We were supportable and validated. You do not want to be the person doing the incredibly unique thing no one else is doing on vSAN. Leave that to our Ready Labs. We'll do the weird stuff, we'll validate it, and we'll help you get there. I'm sure a lot of people can, myself included. vSphere VCGs, vSphere Compatibility Guide, or you might have heard of them as a hardware compatibility list. This is not just a vSAN thing, but I think vSAN really put a lot of eyes towards this concept. vSphere VCG has existed a long time, and that's the parts that work with vSphere. That's your basis for working with vSAN as well. But on top of that, layer on top the disk controllers and disks accepted for vSAN, because I need to consider those and which ones are actually going to work. The HCL will help you here, but what helps you the most, start with a Ready Node. This way, the minimal changes you need to make to get into your environment, the less work you need to do in sizing this out. You also have your local vSAN teams, so make sure to contact VMware. Also work with your partners. Partners have been a tremendous resource because they've seen the whole array of all the Ready Nodes and options out there that can help you break those down.
So one of the things I really love about working with VMware is we take our customer feedback very, very seriously. When vSAN 5.5 came out about, I don't know, what was it, 50 years ago, 60 years ago, something. When 5.5 came out, what we heard a lot of was virtualization admins, you guys don't want to be hardware admins. And that's understandable. You don't want to be hard. If you wanted to do that, you would have just gotten your A+ and been done, right? So what we did is we came up with Config Assist. And Config Assist takes care of your I/O controller, your drivers, and firmware. Right now, we support Dell, Lenovo, Supermicro, Fujitsu. But we put that functionality directly into the vSphere web client for you with vSAN, all right? So click a button, hey, I might need a new driver, a new firmware, whatever the case may be. The health checks will let you know, and it will download it and install it for you. You don't have to log into ILO or iDRAC and upload or SCP stuff over. We don't do that. Config Assist take care of that for you. Another thing that we got feedback on was customers, hey, I'm buying these servers. I want these servers to last me 5 years. How do I know if I'm going to be compatible with the next version of vSAN? What if one of my guys doesn't check the HCL for these drives and suddenly I find out they're not supported? We took care of that for you. VMware Update Manager now, if you are running vSAN, will look at what version you're running, what hardware you have, what drivers and firmware you have, and it will let you know before you upgrade, which is always nice. Before you upgrade, yes, you will be compliant with the next version of vSphere and vSAN, or no, you will not be compliant. So we take the guesswork out for you. And I don't think I can stress this enough. We love our customer feedback. If you guys think we suck, tell us we suck. Tell us what we can fix. We want you guys to be successful. We want you to have a simple, easy life, right? We don't want to make things harder.
Question.
Yeah.
Second-party plugin support for H5 client for vSAN?
Stay tuned.
We'll take that up.
We'll take some more questions at the end as well and make sure we get through the things you have.
Just so you know, we have a lot of stuff to get through. We will take some questions at the end. If we do not get to your question, Ron and I will be outside in the hall afterwards. Please feel free to approach us. Even if you see us walking down the hall, just grab us and say, hey, I got a question. Because that's what we live for. That's what we like doing. So we talked about VUM. We've talked about Config Assist. Let's talk about storage media selection. So right now, I think everyone knows we have all flash and we have hybrid. Now at the cache layer, they're both the same. You've got an SSD, you've got a PCIe form factor, you've got NVMe, which if you haven't seen NVMe in the real world, check it out. Stuff is smoking hot. Love it. And then behind that for capacity, all flash, obviously we have more SSD. If you want to go hybrid, we've got spinning disk, sorry. But what we are finding is the vast majority of our customers who are putting production workloads on vSAN are going all flash. And there's a very simple reason for that, right? It has to do with our space efficiency technologies, our dedupe, our compression, our erasure coding, right? I think we all know SSDs are much faster than spinning. What we are doing is we're taking that extra performance of the SSD and we are utilizing that speed to be able to do the dedupe, do the compression, do the erasure coding, and not affect performance. Okay. So you decided on your storage media, hey, we're going to go NVMe with SATA for capacity, or we're going to go all SAS for cache and capacity, whatever the case may be. So you decided on your media, now you got to talk about disk groups. Disk groups, very, very simple, right? Always one cache disk until you hear differently. Hint, hint. Always one disk for cache. Up to 7 for capacity, 5 disk groups per node. That means 40 disks total, 35 capacity, 5 cache. This next one's a rough one. If you look at KB 212-9050, this is a KB for best practices for putting non-vSAN disks on vSAN I/O controllers. This is a case of just because you can do something, should you? And the answer to that is no. All right, yes, we'll give you best practices. Yes, it is supported. Is that the best case for you? No. Couple reasons. I/O performance troubleshooting. If you've got an extra disk in the mix that is not vSAN, that's going to make things more difficult, right? Performance reasons. You're actually going to hamstring yourself a little bit on performance if you put a non-vSAN disk on a vSAN I/O controller. You know, boot. We've got plenty of boot options, right? You don't need to boot from a disk on a vSAN I/O controller. And then the final thing I want to point out here is cache sizing. So there's been a lot of argument about this. What should cache be? What shouldn't cache be? It's very simple. If you're running hybrid, your cache should be 10% of your usable capacity. Now the question is, what is your usable capacity? That depends on what storage policies you choose for the VMs. Maybe you want some VMs FTT1, some FTT2, some FTT3, whatever the case may be. But you have to sit down, you have to figure out that number based on your use cases, based on the resiliency required, your risk aversion, and then take 10% of it. It's very simple. Okay. Now for all flash, in January of this year, we came out with new guidelines around all flash caching. All right. If you go onto VirtualBlocks, John Nicholson wrote an article about it. And if you go to storagehub.vmware.com, storagehub.vmware.com, check out our vSAN design and sizing guide. There's actually a table there that shows you, AF4, AF6, AF8, which are all flash, different sizes of nodes and how much data can be written to them on a daily basis. And we actually have a table. If you're writing, this type of workload, a 50-50 read-write or a 70-30 read-write or 100% sequential, this is the type of cache you should have. The amount, in general, we're going anywhere from 200 gigs of cache for a pretty small vSAN node up to 1.6 terabytes. But again, go check out that table. That'll give you the exact numbers. All right.
Capacity usage in vSAN is driven by storage policy-based management. Rather than have to get out my Johnny Carson's Kreskin hat, I'm dating myself, Johnny Carson's Kreskin hat and guess how big my LUN needs to be, instead I'm going to be able to use storage policy-based management and decide at the VM level how resilient that ought to be, how that ought to operate. I can even take that down to the VMDK level. In fact, check out on storagehub.vmware.com our reference architecture for SQL. We'll tell you why this is powerful in a practical, real sense when we apply it to real-world workloads. The way I combine and understand this is by knowing about two things. One is my FTT, failure to tolerate. How many nodes can fail before data is at risk? The other is my FTM, failure tolerance method. Is the data stored with erasure coding or mirroring? Out of the box, it's 200% raw to usable. That's the idea behind vSAN by default, that there's 2 copies and a witness for every single object, every snapshot, every VMDK. All these things are going to get 2 copies and a witness. If I want something more space efficient at that failure protection level, I can add another node, go to all flash, and now I can run a 3 stripes and 1 parity distributed across 4 nodes. What this grants me is that same FTT1, but with this all-flash design and erasure coding, it's only 133% raw to usable. I can continue cranking this up and give myself an extra level of failure protection, but notice how much less disk erasure coding provides. Erasure coding needs. That's the point of it there. And the reason I need these increasing number of nodes is because you can see those components that make it up, we never put those on the same node. This protects against double fault. I can crank this knob all the way up to an FTT of 3 that's 4 copies of my data so that I can tolerate 3 simultaneous sudden losses in the same cluster. That is a lot of disk to pay. It's not a request we get all that often to crank to this level, but Josh, do you have some customers that are running that way?
I do, actually. I have a number of healthcare system customers who, things like a fetal monitoring system, things like a cardiac monitoring system in ICU. When people's lives are in the balance, that's the type of resiliency you need is an FTT of 3.
Great point. On top of all this, if I'm running all flash and I'm operating with deduplication and compression, that operates on top of this and gives me additional savings. The disk savings go on top of this FTT cost. We tell folks, plan on a 2-to-1 dedupe and compression. We are very realistic about deduplication and compression. It's an excellent system overall. It's manifested very well in vSAN, but we do not throw out fun 10-to-1 numbers and 15-to-1 numbers on dedupe and compression. We look at real-world data. We look at real-world workloads. Your real workloads are not as similar as sometimes maybe you're perhaps led to believe. 2-to-1 is a great starting point for that planning. Even if that's all I get, even if I just get the 2-to-1, that's paying for my mirroring. That out-of-the-box policy, 200% raw to usable. If I cut that in half, it's 100% raw to usable. So it's still giving me a tremendous benefit. Beyond that FTT, FTM, there are other storage overheads. In any storage system, there's the idea that disks are sized in base 10, computers count bytes in base 2, so you lose about 10% of every disk, and no one's ever going to agree on who's right there, so it's always going to be that way. There's an on-disk format. It's about 1% overhead for each disk. There's checksum space, some dedupe table space. It takes a minimal amount. And then on top of it, there is a slack space concept. Now, this isn't just a slack you add to kind of give yourself some extra space, some extra mercy in vSAN. This is the idea to keep off the proactive rebalance point. vSAN at 80% full will start cycling bits around to keep any individual disk from drowning. It is totally supported to run under those circumstances. But do you want to? Storage systems should be appropriately lazy. So keep it off the point where it needs to do that. So if you're running at 70% full instead of 90% full, you're 10% off that proactive rebalance point. It also gives you a little mercy for when bits are resynchronizing on disks.
And one thing I want to say here is, I explain to customers all the time, hey, we need some slack space. We need that 30% slack space. And they look at me like a deer in the headlights. Slack space? What do you mean slack space? Every single storage array in the world, I don't care if it's EMC, if it's HP, if it's Pure, whatever the case may be, you need slack space. Any array vendor who tells you, oh yeah, we run just as great at 99.9% full as we do at 70% full, they're lying. All right. So just keep that in mind. This is not, 30% slack space is not uncommon at all in storage, and hopefully your storage guys know that.
We make all this easy by offering vSANsizer.vmware.com. STO1372BUR covers this in detail and walks you through a sizing exercise. This is free. You log in with your My VMware account and you can use it today. It does have special use case sizing. You saw that table of the FTT and FTM. I can decide I want 10 VMs running with this FTT, FTM, 10 running this way, and 30 running this way. I can size all that through the sizer, and including saying things like, I want VDI, I want relational databases. It gives you a lot of power to simplify this. When sizing, there's often this temptation to take some perhaps dense storage media or certain designs and go for this cheap and deep perspective. Cheap and deep in all systems is sometimes, maybe even often, neither of those things.
Don't do it.
Think, for example, like a 10 terabyte spinning disk. I thought it was the voice of God for a minute. I felt really affirmed. So think like the 10 terabyte spinning disk. These are on the HCL and they're there for a reason. And I actually have customers using them with great success because they knew what they were getting into. You're talking about a disk that delivers about 100 IOPS on its best day all in. Resyncs are going to take a while. That's a nice way of me saying ages. It's just the nature of the physical media. Nothing we can do. Charlie's a klutz, trips over the power cords in some server, and nobody notices for an hour because Charlie went to lunch and didn't tell anyone. Now all of a sudden you have this resync happening, which vSAN will handle very well. But that's that 10 terabyte disk has to resync, and maybe it's 10 of those 10 terabyte disks. It gets scary at scale. Flash storage media doesn't get slower with size, but that there is this problem common between flash and hybrid. There's a disk engagement question. I don't care how cool your storage system is, disks are your raw horsepower. You have an insufficient count or quantity, then you may run into issues where you're not getting enough disk engagement to deliver the performance level you need. Forget how fast each individual disk is. There's a little power in aggregate going on, including in vSAN. We don't have to go into goofy, crazy things like wide striping across racks and racks. We have some great implementations where we allow you to do this at the node level, but that doesn't mean we want to scale and use as few parts as possible. At the same time, with these designs, do I really want, because Charlie is a klutz and goes to lunch and doesn't tell anyone after he tripped over the servers, do I want 100 terabyte plus resync because a single node failed? Or maybe it failed not because Charlie's a klutz, but because it was 2 in the morning and you just got unlucky. Do I want that size of resync across my network? So think about these decisions when you decide on those disks.
And just real fast, I want to point something out to everyone. Flash storage media isn't slower with size. That is true. However, there is a huge, huge difference between the SAS interface and the SATA interface. allegorical purpose, as I like to say, SAS is full duplex, SATA is half duplex, right? If you have applications that are very latency sensitive and your end users need snappy response and you see SATA, just put a little N on the very end of it, because that's kind of where we're at, okay? I just want, sorry.
Definitely. And if you get time on Wednesday, check out STO1372BUR. Myself and several other industry experts will be talking about vSAN hardware in extreme geek out detail. We're going to hit on some of these topics like the N and SATA and some other things that will help you decide how vSAN hardware can be architected for success. When I'm thinking about these things, I'm thinking about fault domains, and this isn't just a vSAN concept, it's a vSphere concept as well. More nodes give me more engagement. They also give me more fault domains, not just for storage, but also for compute. Think about going that shallow and wide scale out. On the flip side of that, I can run a 64 node vSAN cluster that's the largest size supported today. Should I do it? I do have customers that have built these before. They were usually for testing purposes. One of them built it to see if they could, and they did, and then they took it down because they wanted to say, we wanted to see if we could. Fine. In your practical environment, think about things like you probably have different types of workloads. If you're at the kind of data center where you're running in excess of 60 nodes, anyone at the hundreds of nodes scale? Anyone 100+ node scale? Great. So you do not just run one application across the hundreds of nodes, right? And generally these are split up, not because vSAN can't handle that mixed I/O. It's a champion at mixed I/O, but there's practical reasons. When I'm running at database scale where it's requiring dozens of servers to run my database servers, I'm building different hardware, I'm building different considerations, maybe even different network pods. Think about that isolation. It makes sense. vSAN is designed for that agility. We don't arbitrarily force you into big or small clusters. You get a 45-degree scale out, 90 degrees out, adding nodes, 180 degrees up, adding disks or replacing smaller disks with bigger disks. All of this without VM downtime, using commodity hardware. So take liberal advantage of that.
So I like that phrase Ron used, shallow and wide. All right, I use this all the time with my customers. If you want to get really good performance out of vSAN, go shallow, go wide. This right here, basic, right? One cache, one capacity. Sweet, no problem. Hey, we're gonna scale this up. We're gonna add a bunch of disks to it. Even this is okay. We're not using all the slots, we got more to grow. However, we could get better performance out of this by going shallow and wide. So instead of having just one 1.6 terabyte cache drive, we're gonna put in two 800s, and we're gonna break that into two disk groups. Right? So now we have our I/O going to two different disk groups. We get better performance out of that node. So we want to extend this model out, right? We're going to put in 400s, and we're going to go to our 5 disk groups, and each one has 3 capacities. Sweet! We've got 5 disk groups. We've got 57.6 terabytes raw. This is okay. But here's the problem. You've got 4 slots in that server that you can no longer use, right? Because you've hit your maximum number of disk groups. So what we really want to do, if we want to maximize our capacity and maximize our performance for our disk groups, we want to build them like this. We want to fill the entire server, and it could be 10 slots, 12 slots, 24. Just keep in mind those multiples that will fill it out, be under 5 disk groups.
And you notice we're always making the disk groups evenly sized. vSAN allows you to use differently sized disk groups. Don't. Make life easy.
Don't.
Just repeat. Copy, paste, copy, paste. You didn't want to be a hardware admin, remember? So make it simple. Have a simple, repeatable brick. We like these evenly sized disk groups for a lot of reasons.
Yes, it makes it very easy to do. You call up your partner, you call up your OEM. Hey, I need another one of these nodes that should be built like this. Boom, done, click, right? That's what makes vSAN great, is we can do that. So this is good. This is maximum capacity, maximum performance out of a 24-slot server. But then we go up a level, and our clicker doesn't work. Oh, there we go. Here's an issue. We have all of these disks for all 4 disk groups on one controller. We have awesome performance on these disks. Why are we going to bottleneck ourselves on a controller? So what we're going to do is we're going to add another controller. Again, we're going to break up that I/O path to get the best performance we can, right? Disk group 1 and 2, controller 1, 3 and 4, controller 2. This is excellent performance right here. You know, I have customers who are running nodes like this, and let's see, I have a customer, they're running 15 nodes in a cluster. It's SAS SSD, they're running it like this. They move their biggest workload to one of these nodes, or I'm sorry, to this cluster. And prior to being moved to vSAN, it was running on one of our competitor storage arrays, I won't say which, and they were bottlenecked at 50,000 IOPS, and their throughput was not very good. They moved to a 15-node vSAN cluster. They're getting 400,000 IOPS. Their throughput is something crazy like 1.4 gigs a second, and the cluster isn't even breaking a sweat. All right, that's the type of performance, if you build these things correctly, you can get. Now, there's one more thing I want to point out when it comes to disk groups. Can we do this? Absolutely, we can do this. There is no problem with this at all. However, what I see happen is when people have an odd number of disk groups and an even number of controllers, this occurs. And we split that disk group across I/O controllers. Now, is this supported? Yes. Yes, it is. Should you do it? No. No, you shouldn't. You're going to make your lives more difficult when it comes to troubleshooting I/O. You're not going to get the best performance out of your vSAN node. This is just, that right there, splitting that disk group is bad. You don't want to do that, right? Don't split your disk groups across controllers. Maximize for capacity as well as performance. All right? Those are the things I want you to take away from this. We're thinking this is all flash, and so yeah, that's. But if you go to storagehub.vmware.com, look for that cache sizing table. It'll give you the info on that.
I want to talk quickly about physical networking for vSAN. vSAN is designed to be an incredibly simple commodity network. It is not fiber channel, thankfully. It is not a SCSI, it is not NFS, it is a proprietary networking protocol stack built specifically for vSphere hyperconvergence. This is how we bring remarkable simplicity to how it's designed, how it works, and how it's built. 10 gigabit Ethernet is what vSAN wants. We do support 1 gig Ethernet for hybrid. Can versus should. Don't. The resync times are always a consideration in hybrid. My disks are going to slow me down. They can only spin so fast. We can't make a disk spin faster. When you put that on top of the fact you have a 1 gig pipe, you're hampering a rebuild that you could have made much better with 10 gigs. And the 10 gigs is just node to node to node. So if you're putting this at your enterprise's remote site and they only have 1 gig networking out there, you don't have to rip and replace everything to get this done. You could simply, node to node, ensure 10 gig connectivity. Along these lines, because we're talking about east-west traffic here, east-west traffic is a challenge for fabric extenders, FEXs, like the Cisco 2K and such.
Don't use FEXs.
We have in our network design guide considerations when using a FEX. Josh and I have our own consideration, don't use a FEX. They have their place in the data center. vSAN or heavy east-west traffic where east-west is oversubscribed is not a great fit. You can simply bypass these, save yourself the hassle, have a simpler design. Multicast has been a frequent question in vSAN. The past 2 versions of vSAN, we have not required multicast. Hooray, that makes life easier. Anybody running vSAN 6.5 or below in their environments today, where multicast is still present? Okay, so not a horrifying reality. I need some IGMP snooping, and I need a querier somewhere to head up the network, head up the multicast conversation. Biggest pitfall I've seen there, if you're getting into a 6.5 or 6.2 design, you're not able to go to 6.6 or you're already living with it. A lot of switches, for example, like Nexus stacks will come pre-configured with IGMP snooping on, great, but they're also each a querier. So you start spanning multiple racks, and each rack has a querier at the head with the top of rack, and there's a querier at the core. You get multicast fragmentation. One querier, run it back at the core. Great time to work with your network design team. Also a great session to check out here with Cormac Hogan covering vSAN network design in detail. We get a lot of questions about jumbo frames. Are jumbo frames required or a good idea in vSAN? They are usually inconsequential. You're going to get some CPU savings, possibly, depending on a lot of factors. It's a long string of it depends. What I tell folks is if you normally build your networks out on jumbo frames, if that's something just kind of a matter of course, great, do it. If that's not something you normally do, don't. Make your life simple. In most cases, there's no practical, no big enough advantage to jumbo frames to make it worth the effort. One thing that's absolutely worth the effort, and I think should be considered mandatory, build each vSAN network on its own VLAN. You get over 4,000 of those things. If you're using them all, your network admin needs some mental help. So
need a new network admin.
Take some up and use them for each of your vSAN clusters. Put them on their own VLAN. Storage likes to be on its own network. This gives you security and reliability to operate simply. On the virtual side, this is simple. Use a virtual distributed switch. vSAN uses VM kernels like vMotion does. We give you virtual distributed switch free with your box of vSAN for a reason. That's centralized configuration, that's network I/O control, where if stuff is sharing uplinks, I can make sure each thing is getting the right swim lane. It's the right thing to do. We get a lot of questions about uplink assignments. This is actually a little diagram, a simple diagram of how the VxRail G series works. It's a 2U 4-node appliance. Each node has two 10-gig ports, A and B. vMotion management run off of A, vSAN runs off of B, they fail over for each other. Active passive design, very simple. If I had a few more 10-gig ports, I could spread things out a bit here. I can give a little bit more freedom to swim around. Maybe I could add some service like replication onto the link. Each case, I'm doing a simple active-passive failover stack. There's a lot of ways to do this. This is a nice, simple way to operationalize with it. We do support aggregation. For example, LACP, part of the great feature set of distributed switches, that lag integration. And if that is something you normally build at scale in your data center, you're very comfortable with it, go for it. If it's not, you probably don't need it. When aggregating 1 + 1 does not equal 2. Two 10-gig links does not a 20-gig link make, and vSAN is designed for a 10-gig link anyway. And I will tell you that in the real world, I get to see a lot of very esoteric and interesting research clusters and other funky things. Pressing vSAN actually up to the 10-gig point takes some serious work. So this is not designed to require an aggregation, but it is supported.
So with storage policy-based management, we've got these FTTs, we've got our resiliency, we have our performance. As you can see, we have storage policy FTT by 3, right? When a policy is selected, vSAN actually rearranges the components of your objects in real time. You don't have to power things down. You don't have to restart workloads. However, what you have to do is use your brain, because if you have, 50 terabytes of VMs and you're going to change them all from FTT1 to FTT2, and you create that policy and you click hit apply to all of your VMs, you just dumped terabytes of data onto your network. And that's right around the time your network takes a dump. So be very careful with that, all right? I think what I've seen work best operationally is you create a new policy and you migrate small groups of VMs to that policy. Wait for that resync to finish before you move your next batch, all right? Just use common sense. So cluster configuration settings, cluster-wide deduplicate compression we talked about, activates on the whole cluster. When you turn it on, there is a disk format conversion. This takes a little bit, all right? It's better to turn it on before you have data on your cluster. If you have data on your cluster and you turn it on, it's going to take a long time to do its thing, all right? So if you want it, do it before you put data on your vSAN cluster. And another thing to keep in mind is with deduplicate compression, each disk group becomes its own fault domain. That data, the deduplicate compression, that table is striped vertically down your disk group as well as the dedupe and compressed data. So if you lose a disk inside that disk group, you'll actually lose that disk group. Now you're not at a risk of data loss because you're hopefully at least FTT1, but it is something to keep in mind. If you have dedupe and compression turned on, you lose a disk, you lost the disk group, okay? STO1372BUR, deep dive, vSAN native encryption. We love vSAN native encryption, right? Currently, we've got the VM encryption too. That's hypervisor level. It doesn't matter what, it's storage agnostic, right? But you don't get dedupe and compression. But with vSAN data at rest encryption, you would encrypt the entire data store, right? It works with deduplication, works without compression. You have to have a KMIP 1.1 key server. These are just a couple. These are by no means a comprehensive list. I just wanted to show you a few. And this, you can actually transition from VM encrypt to vSAN data at rest encryption. And vSAN data at rest encryption, they work fine with encrypted vMotion. All right, and I shouldn't say work with because they don't actually touch each other. They're two completely separate things, but you can utilize both technologies on your vSAN cluster.
There are special topologies available in vSAN to further enhance your design, to take this knowledge and then think about how do you want to operate vSAN at your scale. For example, there are fault domains for rack awareness. This is the idea that normally the node is my fault domain. If I have an FTTO1, I can lose any node, I don't care which, and I won't lose data. What if I want to take that up to the rack level and say, I want to lose any rack in my data center and not lose data? It will take multiple nodes, group them into fault domains, starting with at least 3, going out to 7, depending on the policy I want across those. And now I can lose at the rack level an entire rack. This is another example of that high-level resiliency. We see this in some of our customers where there's a need for high resiliency. Anyone running 5 nines, or I hope not, but higher? Anybody doing something fun like that? So we have a few 5.9 shops under 5.9's SLAs. They sometimes do stuff like this, fault domains. Stretched clustering is the idea of active sites. One cluster across 2 physical sites. We use a witness at a 3rd site because split brain protection. If site A can't see site B, you don't want them booting the same VM, making different writes. So we use a small witness. It's a VM. It can run in the cloud, it can run at your remote sites, it could run at a different data center, it can run in a phone closet. I've seen it in all kinds of places. It is a simple VM and very easy to manage and use that way. The idea here is when you're building stretch cluster, the easiest way to think of it, though there's a lot of things you can do, let's keep it simple. Even with the enhanced local protection, where you can have multiple copies per site, build site A, copy paste, there's your site B, your stretch cluster design is done. That's the basic idea behind stretch clustering. You can also, besides a synchronous replication, you can do asynchronous replication. This is more the DR versus DA, disaster avoidance versus disaster recovery argument. That's where Site Recovery Manager comes in. The big red button for Site Recovery figures in, and vSphere replication comes free with your box of vSphere, and Site Recovery Manager sits on top of that and gives you the big red button failover for failover and testing. You can do a 2-node direct connect architecture where, and like we mentioned before, these are 2 data nodes out of the site. They each have a copy of the data. You can directly connect them together, and should, most likely. Take a twin-X cable, 2 Cat6 cables, whatever. You're going to connect those 2 together, and that's going to give you your entire site there. You're going to run a witness VM, again, always protecting split brain. If you don't protect split brain, you're not a storage system. So we always protect split brain, and we're going to run that witness VM usually back at the main data center. You can run that one in the cloud as well. Tolerates 500 milliseconds of latency. I have people running these across continents, the witness to the 2-node. Pretty cool stuff. Backing up is a simple story for vSAN. vSphere APIs for data protection have existed since ESX4. The idea here is that there's an API set that backup vendors use to back up your data. And when they use these backup APIs, they can back up vSAN just fine. They don't need to know or care that's vSAN. Now, some vendors, such as these, plus several more listed, have gone out of their way to create special documentation and even special software features for vSAN customers, which is really cool. If you get time, check out STO1372BUR. Shoban will be giving you a preview of some icing on the cake, some additional things we're doing in the world of vSAN data protection to push this further. I want to say that moving data around inside the same system is not a backup. Snapshots are not a backup.
No, they aren't.
Snapshots and replicating them somewhere else is not a backup. All of those things can be the great first step in a backup flow. Many backup products work by starting with a simple Quiesce snapshot. That's fine, but that's not the end game. You probably heard the 3-2-1 rule: 3 backups, 2 storage media, 1 of those being off-site. A great simple rule to give you an idea to make sure your backups have a flow and something to recover from should disaster strike. Secondary storage has come along pretty recently and really made the story even sweeter. Things like Cohesity and Rubrik, where now I'm not just backing up and moving the data off-site and around to different storage media. I can boot certain VM workloads in a pinch because there's nowhere else to boot it, which is fantastic.
All right, so we've gone over a bunch of this stuff, right? We've talked about evaluating, setting up your use cases, how you should design it. If you need a proof of concept, run a proof of concept. User acceptance testing, have your end users test it before you roll it out. Make sure it's at or better than what they're expecting. Certify, make sure, if you can get an application that's certified for vSAN, by all means do so. Certify your stuff internally. Hey, does this work on this? Yes, no. Go live, validation, make sure, in no way, shape, or form would we ever condone a rip and replace of storage with vSAN, all right? Roll it out small pieces. Use your common sense. You guys know how to do this. You're good engineers, or else you wouldn't be here, all right? And each of these things above, they depend on engagement with your business owners, your end users, your storage guys, vert guys, networking guys. You have to talk to all of them. And really define your success criteria. If you'd like a little light reading, our vSAN proof of concept guide is on storagehub.vmware.com. It's only about 280 some pages, so it'll go quickly.
You are allowed to skim it.
Yes.
It has chapters for a reason.
We're actually getting G.R.R. Martin to write our next version of the POC guide.
In that version, everybody dies at the end.
All your nodes are dead. No. Storagehub.vmware.com. All right, I'm going to give you 10 seconds here. Get out your cameras. You're going to want to take a picture of the next slide. All right? So you got 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Here we go. This is everything you need to know. Look at you guys. That's awesome. I love it. All right. These are all the resources. I mean, everything you could need. StorageHub.vmware, all of it. Ron's blog, twoo.net. You can catch me on Twitter, JCEFidel. We've got just a couple minutes left. If we can get 1 or 2 questions, and again, we'll be outside in the hall if you have questions. Does anyone have? Yes, sir. Come on up.
Feel free to step up to the mic there, too.
Do it.
I got a big voice. I don't need a mic.
Good. I like it.
Any possibility of a future release having a compression enabled but not necessarily dedupe?
So the purpose behind chaining deduplication and compression is because of the I/O flow. There is a session called A Day in the Life of a vSAN I/O. It is yet to come. I think it is tomorrow. Check your schedules. It will walk you through the purpose behind the chain dedupe and compression, when that happens in the inline I/O flow story. There's not a lot of practical benefit in separating here, although I have heard some use cases of things where people say deduplication is actually not going to work at all in this environment, but compression will. We'd like to unchain them. The best thing I will say, send that feedback. Make sure VMware hears that. We're happy to take that feedback back to VMware for you. Come up and grab us. We're happy to talk with you about it in detail. Any other quick questions?
Yes, sir. Right here.
I have several, so I won't follow y'all.
Absolutely.
That's cool.
One other question, question, is there going to be possible that maybe not storage policies to disable people on a VM basis?
At this point, it is a cluster level, and this is because we actually reformat, we do a disk format conversion, and we do this at a disk level. This is because deduplication, if you do it purely in software and the disk has no idea how the bytes are scattered, it's less efficient. So at this time, dedupe compression is a cluster level configuration. It does that, as Josh mentioned, that disk format conversion change, and that will make a difference there in terms of how vSAN will operate with that dedupe compression on. So at this point, it is not an SPBM setting.
Oh, look, beard right there.
You got a couple slides about what vSAN's really good at.
Right. What do I not recommend? I don't recommend video editing. That's...
Depending on your scale, video editing can be a challenge for any storage system except one specialized for it. I do have a customer running video editing at scale on vSAN with success. Some careful design and thought was coming into that. Stay tuned, we are writing our reference architecture for video streaming systems like high-def cameras and stuff. We are paying attention to that special niche market. The idea behind vSAN was start with the 95% of use cases out there, then start lasering in on the tricky ones. Video editing is a very tricky workload.
Yeah.
Anything heavy, large batch sequential writes is tricky. Whether it will work on vSAN is a matter of knowing the specifics in the assessment. Great time to work with your VMware partners. Great time to work with VMware. We can help you kind of laser in on that. If you have some specific workloads you have questions about, feel free to grab us. We can kind of start talking down that line.
All right, guys, we got to call it. We will be right outside in the hallway. Thank you very much. Hey, just so you guys know, you're going to get, thank you. You're going to get your survey. Hey, we like feedback. If we sucked, tell us we suck. You know, we'll fix it next time. We'll be better, promise. If we're awesome, tell us we're awesome. Actually, if we suck, tell us we're awesome. So
we're fragile.
Yeah, right. Thank you very much.
Thank you.